Many years ago, I purchased this Weiser Keypad lock to allow friends and family to enter the home if they were coming for a visit and we weren't home. I hadn't used the lock in over a year and I had a visitor coming in, so I decided to go over and program the lock to allow them to enter, only to find out that the keypad had failed on it and basically it had failed open. It would no longer control or be able to program the lock. And as you might imagine, that meant both of us had to change our plans for me to be available to let them in. So I basically just forgot about the lock for a little while. Then, being a computer and electronics geek, I found out about these new ESP32 controllers by Expressif and decided to look into those as a possible upgrade to the lock. After pulling the cover off, we can see the front side shows the little buzzer, a programming button, a door direction jumper, the motor, and then the capacitor showing from the other side. Flipping the board on the other side, we see the main processor, the connector for the keypad, and the motor drive circuitry. Okay, returning to the previous view, let's take a look at something I didn't mention. You'll notice there are printed circuit traces on this side of the board. The top one is marked open and the bottom one is marked close. This definitely might have something of interest to me as I decide to reuse this lock without the keypad. Well, I decided it was worth exploring this one further, so I've got a whole bunch of these BC107 transistors. So I just soldered up a 1K resistor between the collector and the base and decided, well, I'll just jump out the trace and see what happens. And sure enough, the lock would trigger. It worked just fine. I can open and close the lock just by jumping out these traces. It did mandate that the emitter be on the bottom and the collector be on the top. Okay, now's the time to start doing some development work and testing and see if this is even practical. First thing I did, of course, was purchase one of these, an ESP32 Room 32D, and I did all my development work on this one using a base program that I found in the Arduino library. Okay, the plan here obviously is I only have software inputs, but I have two outputs, and according to everybody's recommendation, I picked up a couple 817 opto isolators and proceeded to solder them to a little piece of prototyping board in the anticipation of interfacing them with the switches, with of course the output being able to trigger the open and close as we see in the previous description. Now if you look closely on the underside here, you'll note that there are two 470 ohm surface mounted resistors soldered in here, and I cut the trace in one spot here on these two so I could insert these, and that way I didn't have some large resistors hanging out above. I had already programmed this and prototyped this using the ESP32D, and it all worked perfectly. And it would definitely work for triggering the open and close printed circuit traces on the main lock board. Okay, right about now I'm feeling pretty good. It all prototypes out, it all works using the ESP32D controller. So I purchased three of these little Seeed XIAO controllers. Obviously the bigger controller was not going to fit inside the lock and allow sufficient room for the little board and a little power supply to be in there as well. So I needed something a little bit smaller, so I went with this controller. I bought three of these from DigiKey, and they include the little antenna that goes with them, and they're only $5, but of course with DigiKey you do have to pay shipping. And now the only other modification that really makes a difference was to slightly notch the casing to allow the processor to be plugged into a cable. And it was time to test the unit, and I'm really stoked, and I figure she's going to work like a champ, and it don't work. Okay, the first lesson. These little Seeed controllers cannot generate much output current. The big boy ESP32 had no trouble driving the opto isolators with a 470 ohm resistor. This one couldn't drive them at all, period. It would just drop down so low that there was no current to drive the opto isolator. Okay, as you see here, my interim solution was to use the Seeed controller to drive the base of a 2N2222 transistor and have a 82 ohm resistor in series with the transistor and the opto isolator. This would actually work. However, it also created a severe voltage drop on the Seeed controller. Okay, before we go any further, here is the screen that you get from this program on an iPhone or on a computer. Of course, it's fairly small on an iPhone and it's fairly large on a computer. I have not tested this program with an Android device. That would be for one of you to try and perfect. Now, when I say the output on C controller was dropping low, I do mean very low. It was dropping under 2.5 volts. And at that voltage range, I thought I just might damage the processor, so it's time for a reset. My first thought was to do this. Basically, of course, I was using the FET to drive the oppo isolator. Okay, so this time I'm doing the smart thing. I'm going to prototype it using one of my Seeed controllers, and I'm going to do the actual circuit you see here. And yes, it works just fine as a prototype. No problem at all. I can drive the opto isolator, and it should interface very easily, of course, with the actual control board itself. And okay, it's about this time. The light of logic turns on and says, "Hey, dummy, why don't you just drive the board directly with the FET? Don't even use an opto isolator." Okay, now, same deal as before. Take a 2N7000 FET and then a 1 mega ohm resistor from the gate to the drain and test trigger the board, and sure enough, it works. Okay, next lesson with these controllers, of course, is FET outputs are probably the best way to go. Okay, so here's the almost final project. I'll explain that statement shortly. What we have is a Seeed controller. The prototyping board I left in place because I had all the connections soldered up. I also have a 0.1 microfarad capacitor in parallel with the processor power, as well as a 1000 microfarad capacitor, 6.3 volts, in parallel with the power. Voltage regulation here is supplied by a 1117 surface mounted voltage regulator, and this is where the next little surprise came in. Okay, as you can see here, it clearly still does work. There are a few catches, of course, there always are. In the case of an iPhone, you actually have to press the lock or the unlock on the screen twice to get the lock to activate. This is not the case with a regular computer. Just one touch causes the lock to activate or deactivate. Now, in the case of the iPhone, it's usually easier to have two tabs programmed into your browser, one for lock and one for unlock. This is done using the address, the front slash, capital L, lowercase OCK, and then for the other, capital U, N, LOCK. Now, as I said before, this little project had one more little lesson to teach me. In this case, the small linear voltage regulator apparently was using an awful lot of quiescent current, even when the processor was basically off. This little circuit was going through 4 batteries in less than a week. So, okay, I had to find another way. That's not going to cut it for battery life. After going through a couple sets of batteries, I started looking around on eBay for a better alternative to this little regulator and found this little regulation circuit from our Chinese friends. They were only about $3 each. I bought 2 of them. One is in use here, and this definitely cured the battery killing problem. Right now I can have 4 batteries last 3 weeks to a month with no trouble whatsoever, and it would probably last longer than that. That's just as long as I tested. Okay, I'm very happy with this little project. It only works within range of the router, which of course means you can pull up in the driveway and unlock the lock without any trouble. So that meets my needs. I did not want it to go out over the entire internet. And again, you probably could do that by punching some holes in your router firewall if that's what you want, but I only wanted this lock to operate locally. Well, thanks for watching. Hope you found this interesting and useful. This is definitely something to consider if you have an old keypad lock that no longer works off the keypad, but you want to convert it to an internet-based locking application. So I would recommend this for that one. Please consider giving me a like, and if you found this especially interesting, you might want to check back and definitely consider subscribing, because I've got a few other projects coming along with ESP controllers I think you're going to want to probably see. So until our paths cross again, y'all take care now and have a great day and a great week.